So, let's go. Number 1, the inflating sea. Here's the thing nobody tells you when they say the universe is big. The universe might not be the big thing at all. It might be a single drop. Back in 1980, a physicist named Alan Guth was trying to fix a few annoying problems with the Big Bang, and he came up with an idea called inflation. For the tiniest sliver of a second after everything began, space didn't just expand. It exploded outward, doubling, then doubling again, faster than you can imagine, faster than light. That part most scientists now accept. That part is almost boring. Then a man named Andre Linde looked closer and found the horror inside the math. Once inflation starts, it doesn't like to stop. It stops in little patches here and there, and each patch that calms down becomes a universe. But the space around those patches keeps inflating. It keeps boiling. And it boils faster than the calm spots can spread. So picture an ocean that is always violently expanding, and every now and then, a single bubble goes still and quiet and becomes a whole cosmos with its own stars and its own rules. Your universe is one of those bubbles. The ocean around it never stopped. It is still out there right now, inflating, making more bubbles, and it will do this forever. How many other universes does that make? Not 1,000. Not 1,000,000,000. An infinite number. More than you could ever count, because they are still being made while you count. And here's the part that should bother you. You can never visit a single one of them. The space between your bubble and the next is inflating faster than light can cross it. So those universes are real, they are out there, and they are moving away from you forever, faster than anything could ever follow. Each one might run on different rules, different gravity, different particles, different physics entirely. Somewhere out in that endless sea, there is a universe where the number that holds atoms together is just a hair off, and nothing can exist there at all. You are not living in the universe. You are living in one of its children. And the parent is still giving birth, out past an edge you can't see, in a sea that has no shore. So if the sea is endless, what's floating in the rest of it? Number 2, the mirror before the Big Bang. You've always been told the Big Bang was the beginning, the first moment. Before it, nothing. After it, everything. A clean wall with us on one side. 3 physicists looked at that wall and asked a quiet, terrifying question. What if it isn't a wall at all? What if it's a mirror? Their names are Latham Boyle, Kieran Finn, and Neil Turok, and in 2018 they published a theory built on the deepest rule physics has. It's called CPT symmetry. Strip away the jargon and it says this. If you flipped matter into antimatter and flipped space like a reflection and ran time backward, the universe would behave exactly the same. The laws don't care. This is not a fringe idea. It's one of the most tested truths we have. So Boyle and his colleagues said, fine, let's take it seriously for the whole universe at once. And the math handed them something nobody asked for. On the other side of the Big Bang, stretching backward in time, there is another universe. It is made of antimatter. Its space is flipped, like a reflection. And its time runs the other way, away from the bang, not toward it. Our universe, and that one didn't come from the Big Bang one after the other. They came as a pair, a universe and an anti-universe, born back to back out of the same single point, growing in opposite directions of time. Sit with that. Somewhere behind the moment you call the beginning, there is a mirror cosmos getting older in the wrong direction. If anything lives there, it doesn't think it's living backward. To them, you're the one in reverse. And the theory does something a good ghost story never does. It pays rent. It predicts that the dark matter we've been hunting for decades is one specific particle, a heavy, quiet thing almost 500 million times heavier than the core of a hydrogen atom left over from how the pair was born. That's a real number. That's something we can go look for. We might confirm the mirror exists by finding what it left in our pockets. The Big Bang was never a door you walk through. It was a surface you were reflected in, and your reflection is still out there, getting older, on the far side of time. Which raises a worse question. If there's something behind the beginning, what's beside us? Number 3, the other membrane. Reach out and wave your hand through the air. It feels empty. It is not. According to one of the most serious ideas in modern physics, your hand just passed a fraction of an inch from another entire universe. The idea comes from string theory, and it goes like this. What if everything you know, every galaxy, every star, all of space, is a thin sheet, a membrane? Physicists shortened that to brane, and this sheet floats inside a bigger space with more dimensions than you can see, a space called the bulk. You can't look into the bulk. You can't point at it. Every direction you point already lies flat along your own sheet. The extra direction, the one that leads off the membrane, is a way of moving your body simply cannot do. It's not far. It's perpendicular to everything. And here's where it stops being abstract. In 2001, 4 physicists, including Neil Turok again, proposed that there is a second sheet. Another universe, parallel to ours, hovering across that hidden gap. For most of forever, the 2 sheets drift slowly toward each other. And when they touch, everything ignites. They called it the ekpyrotic universe, from an old Greek word for being consumed by fire. Because in this theory, the Big Bang wasn't a birth out of nothing. It was a collision. 2 universes slammed together across a dimension you can't see, and the energy of that impact became all the matter and heat and light in your sky. Everything you are is the bruise left by 2 worlds hitting each other. And in the cyclic version, it isn't a one-time thing. The sheets bounce apart, drift, and fall back together. Crash. New universe. Drift. Crash. Again. The Big Bang. You think of as the start of time might just be the last time the other membrane touched ours. It's still out there. It's still coming back. So the other universe isn't a billion light years away. It's not past the edge of anything. It's right here, laid over your whole world, one impossible step to the side, waiting to fall into us again. But if another universe can hide one step sideways, what else is hiding closer than that? Number 4. The hidden universe sharing your space. Look around the room you're in. Now consider that scientists think a second universe might be standing in it with you, not far away, not in another dimension. Here. Overlapping your chair, your walls, your body. A whole parallel set of stuff, woven through the exact same space, and you can't feel it, and it can't feel you. The idea is called mirror matter, and it's surprisingly elegant. Take everything we're made of, every particle in the rulebook, and imagine a complete second copy. A mirror proton. A mirror electron. Mirror atoms building mirror rocks and mirror stars. Same masses, same forces. Just flipped, like a reflection of the whole instruction manual for reality. Now here's why you've never noticed. This mirror stuff barely talks to our stuff at all. Light from our world can't touch it. Your hand can't push it. The only thing the 2 worlds share is gravity, a faint mutual tug, and nothing else. So the mirror world is, to us, completely dark, invisible by its very nature. You already see where this is going. We have spent 40 years hunting for something we call dark matter. An invisible weight that holds galaxies together, that outweighs everything we can see, and that refuses to show itself in any detector. Mirror matter is one of the leading suspects. The thing that anchors the entire Milky Way might be a ghost universe, hanging in the same space as ours, made of atoms we will never hold. And it gets stranger. If mirror matter exists, it can clump, it can form mirror planets, mirror stars that shine with a light you can never see. There could be a mirror world drifting through our solar system, a dark twin of Earth passing through the room you're sitting in, and the only sign would be the faintest pull on a scale. Right now, scientists are running experiments trying to catch one of our particles flickering across into the mirror side and back, trying to knock on the wall between the 2 worlds and hear if anything knocks back. So the universe next door isn't next door. It's inside the door. It's inside you. And once you accept that another universe can share your exact address, you have to ask whether the others out there even play by the same rules. Number 5, universes with the wrong number of dimensions. You live in 3 dimensions of space, left and right, forward and back, up and down. It feels obvious. It feels like the only way a world could possibly be. It is not. It might just be the only way that doesn't immediately die. In 1997, a physicist named Max Tegmark asked a question that sounds like a child's question and ends like a nightmare. Why 3? Why not 2 dimensions of space, or 4, or 7? And when he ran the physics for every other option, he found something cold. Almost all of them are dead. Give a universe 4 dimensions of space instead of 3, and atoms stop working. The force holding electrons to their nuclei goes unstable. Planets can't hold a steady orbit anymore. They either spiral into their star or fling off into the dark. Nothing lasts long enough to become anything. The whole place is born and falls apart before a single thing can grow. Go the other way, down to 2 dimensions of space, and you get the opposite problem. There's not enough room. Gravity barely functions. Nothing can get complicated enough to think a single thought. A flat, simple, empty kind of nowhere. And then there's time. You have 1 dimension of time, and Tegmark showed that's not an accident either. Give a universe 2 dimensions of time, and cause and effect fall apart. Nothing can predict anything. Throw a ball, and there's no fact about where it lands. A mind couldn't function, because thinking needs 1 moment to lead to the next. So out in that endless sea of universes from a few minutes ago, this is what's floating in it. Worlds with 4 dimensions where everything crumbles instantly. Worlds with 2 where nothing ever happens. Worlds where time runs sideways and nothing can ever make sense. Universe after universe after universe, almost every one of them a stillbirth. And yours is one of the rare ones that works, not because someone chose it, just because the dead ones have no one standing in them to notice they're dead. You're not living in a normal universe. You're standing on the one habitable island in an ocean of drowned ones. But even on this island, the floor might not be as solid as you think. Number 6. The 2-time universe. There's one thing you never question. You can argue about space. Up, down, far, near, fine. But time, you trust. Time is the single arrow. 1 past behind you, 1 future ahead. A line you ride in 1 direction whether you like it or not. Now, a physicist at the University of Southern California named Itzhak Bars wants to take that away from you. Starting in the late 1990s, Bars began building something he calls 2-time physics. And it is exactly as upsetting as it sounds. He proposes that the real complete description of reality has not 1 dimension of time, but 2. 2 separate directions of time at right angles to each other. The way left is at a right angle to forward. Try to picture it. You can't. Your brain has no slot for it. A second kind of future, perpendicular to the one you know, a direction you could move through, time that isn't forward and isn't backward, but somehow off to the side. Nothing you've ever felt prepares you for it, because your whole life has been lived on a single thread of time, and Bars is describing a sheet. So why would anyone believe this? Because the math is generous. When Bars adds that extra dimension of time, along with an extra dimension of space, the equations of physics get cleaner. Problems that look separate down here turn out to be the same single thing seen from different angles up there. A free particle drifting through space and an electron trapped in an atom can be 2 shadows of one object living in this larger reality. That's the word that should stay with you. Shadows. In 2-time physics, the world you experience, your 1 line of time, might be a shadow. A flattened projection of something fuller that casts it. You're not seeing the whole shape of time. You're seeing the outline it throws on your wall. And there might be inhabitants of that fuller place for whom your entire life, birth to death, start to finish, is just one frozen edge of a much bigger picture. So even time, the one thing you were sure could only point one way, might be wider out there than you can hold in your head. Which leads to a question that turns this whole thing personal. Where did our universe even come from? Number 7, the universe that gave birth to ours. Every universe we've talked about so far just sort of exists. It's out there. Fine. But a physicist named Lee Smolin asked a different kind of question, a biologist's question. Where do universes come from? And his answer turns the whole cosmos into something alive. In 1992, Smolin proposed an idea he later called cosmological natural selection. It starts with black holes. You know them as the things that eat. The points where matter falls in and is crushed out of existence. Smolin says the matter doesn't end there. He says on the other side of a black hole, a new universe buds off. A baby. So every black hole in your sky is not a grave. It's a birth. And that means your universe, with its hundreds of billions of black holes, is constantly spawning offspring. Whole new cosmoses blooming off the inside of every collapsed star, each one sealed away where you can never see it. Now here's the move that makes it brilliant and disturbing at once. Smolin said each baby universe inherits its parents' rules, but with tiny random changes, like mutations. And a universe whose rules happen to make lots of black holes will have lots of babies. A universe with bad rules, few black holes, dies mostly childless. Generation after generation, the cosmos that survive are the ones tuned to make black holes. Do you see what that means about you? The conditions that make a universe good at building black holes, lots of matter, the right kind of stars, the right strength of forces, are nearly the same conditions you need to make carbon, and planets, and life. We always wondered why our universe seems so suspiciously well set up for us to exist. Smolin's answer is chilling in its simplicity. We're not special, we're just well-bred, we're the descendants of a long line of universes that got very good at reproducing, which means our universe has a mother, and a mother before that. Ancestors stretching back through generations of cosmic death and birth, every link in the chain, a black hole somewhere in a universe that no longer remembers us. And out there, branching off our own black holes, our children are already growing up, with rules a little different from ours, who will never know our name. You're not in a thing, you're in a bloodline. But not every universe out there is content to stay on its own side. Number 8. The vacuum coming to kill us. Here's a comforting thought to ruin. You assume empty space is as empty as it gets, the lowest it can go, rock bottom, the floor of reality. It might not be the floor, it might be a ledge, and there might be a long way down. Physicists call this the false vacuum. The idea is that the emptiness our entire universe is built on may not be truly stable. It might be sitting in a comfortable dip, like a ball resting in a small valley partway up a mountain. It looks settled. It's been settled for almost 14 billion years. But there's a deeper valley somewhere below, a true vacuum, a lower and more stable kind of nothing, and our whole reality is just waiting in the higher one. In 1977, a physicist named Sidney Coleman worked out what happens if any tiny patch of space ever slips down to that true vacuum. And it is the quietest apocalypse ever described. A bubble forms. Just one somewhere, maybe out past the edge of everything you can see, maybe closer. Inside that bubble, the laws of physics are different. The constants change. Atoms, as you know them, cannot exist in there. And the wall of that bubble does not sit still. It races outward faster and faster until it's moving at almost the speed of light. And it does not slow down, and it does not stop. Here's the part that takes the air out of the room. Because the wall travels at nearly light speed, it outruns its own warning. There's no flash on the horizon, no rumble, no bad day where scientists go on television and tell you to say goodbye. The wall and the light that would announce it arrive at the same instant. One moment you exist, the next you don't, and there was never a moment in between where you knew. And it doesn't leave wreckage. No fire, no debris. Coleman showed the bubble leaves behind only smooth, silent, true vacuum. A clean nothing where a universe used to be. The truly unsettling part. We don't actually know if our vacuum is the real floor or just the ledge. And scientists have now started simulating these killer bubbles on quantum computers, watching tiny versions form and grow, trying to understand the thing that might already be on its way. Somewhere out there, the end might already be expanding toward you at the speed of light, and you would finish this sentence either way. So maybe the safest move is to stop looking outward and ask what the edge of the universe actually is. Number 9, where time becomes space. This is where the video quietly changes. Everything until now was a thing out there. A sea, a mirror, a membrane, a bubble. Now, 2 of the smartest people who ever lived are going to suggest the question itself is broken. And it starts with the strangest idea on this list. In 1983, James Hartley and Stephen Hawking proposed something they called the no-boundary universe, and the heart of it is this. As you travel back toward the very beginning, toward the Big Bang, time stops behaving like time. It softens, and right at the edge, it turns into space. Read that again slowly. The thing you call time, the one-way river you've ridden your whole life, becomes just another direction of space when you get close enough to the start. There's no first tick of the clock, no hard wall labeled the beginning. The closer you get, the more time melts into another dimension you could walk around in, like turning a corner. Hawking had a way of putting it that's almost gentle, and that's what makes it land. He said asking what came before the Big Bang is like standing at the South Pole and asking what's south of you. There's no answer. Not because we don't know it yet, because the direction itself stops existing. Every way you turn at the South Pole is north. Every way you turn at the beginning of time is forward. So the universe, in this picture, has no edge. Not a wall with something on the other side, and not a wall with nothing on the other side. It's smooth and it's finite, and it simply closes off on itself, like the surface of the Earth. You can travel the whole thing and never once fall off, because there is no off. And that's what flips this entire list on its head. For 8 items we've been pointing outward, naming the things that live past the boundary. Hartley and Hawking are standing at that boundary, telling you there might be no past it. The boundary curves back into the universe. The door you were looking for is part of the room, which leaves us with the worst possibility of all. Not what's outside, whether outside is even a thing. Number 10. There is no outside. You've spent this whole video imagining a horizon, a wall around everything, with you on the inside, peering out at seas and mirrors and bubbles. It's the most natural picture in the world. And it might be completely wrong. Here is what most cosmologists will actually tell you. And it's stranger than any monster on this list. Space is not a stage the universe sits on. Time is not a clock ticking in some outer room. Space and time are part of the universe. They were created with it. They are features of the thing, not the container it came in. So, when you ask what's outside the universe, you're quietly assuming there's a there to point at. An empty room beyond the walls. But if space itself only exists inside the universe, then there are no walls, and there is no room. The Big Bang wasn't an explosion into some waiting darkness. There was no darkness waiting. Space didn't expand into anything. It just expanded, stretching from the inside, making more of itself as it went. And this is the part that does something funny to your stomach if you let it. Outside the universe, there isn't nothing. Nothing is still a thing. Nothing is empty space with no stuff in it. And empty space is already part of our universe. What's outside is not even empty. It's not dark. It's not cold. It's not big or small. There's no word for it because every word you have was built inside the only place the words can exist. Scientists put it the same way Hawking did. Asking what's outside the universe is like asking what's north of the North Pole. You can say the sentence. It sounds like a question. It has the shape of a question. But there's nothing for it to be about. The direction runs out. So after all of it, the seas and the mirrors and the membranes and the killer bubbles, the most disturbing thing scientists think exists outside the universe might be the one thing you can't picture at all. Not a wall, not a void, not nothing. Just know, there. The universe didn't leave a window for you to look through that you could have lived with. The worst truth is that it didn't leave a wall either. There's no edge to press your hands against, no far side to wonder about, no outside to be afraid of. The universe doesn't end. It just stops being a question, and somehow, sitting here inside the only there that exists, that's the loneliest thing of all.